Internal Routing Protocols Part 7, Understanding and Configuring ISIS. This nugget is going to be focused around what many people consider to be the strangest internal routing protocol out there, and that is intermediate system to intermediate system, or ISIS. And this, I think, is going to be the most traditional training nugget, I think, of this entire CCIE series. Now, if you've gone through many of the other nuggets, you've probably got a good feel that this is a lot of hands-on, a lot of configuration, lots of practicals, examples of real configurations and so on. The reason I tweak this more to a traditional style of training is because not many people have much experience with ISIS, even by the time they reach the CCIE level. And the reason why is not many networks are using it in the real world. It's primarily large internet service providers that have been around for many, many years. So what we're going to do as we go through this nugget is spend a lot of time on the concepts and make sure we iron those out. First question I have to ask is, does IS minus IS really equals 0? And that's a joke that a lot of OSPF people say. Don't ever try and tell it to your significant other who's not in IT, because they probably won't get that one. There has been a fierce competition between OSPF and ISIS, and ISIS kind of lost, I guess you could say. So I'm going to talk about why it's still around, why it's still a testable concept when we talk about the CCIE lab. Then we'll get into the facts about ISIS, why ISIS is the way it is, and then we'll get into something about OSI addressing. I can't wait till we get there, because a lot of people think, isn't the OSI just a model? We'll kind of demystify that once we get there. We'll finally look at network design with ISIS. How do you design it? If you just got out of the OSPF nuggets a moment ago, you saw the areas, stub areas, and so on. Is that still around with ISIS? Finally, we'll get into the configuration. And the configuration of ISIS is really a piece of cake, especially when you compare it to OSPF. There's really mainly 3 major commands you'll use to set up ISIS, and we'll do it and we'll walk through it and set it up on some live routers. So let's start off with the big question. Does IS minus IS really equal 0? Well, the flat answer to that is no. ISIS, in my opinion, is a really spectacular routing protocol. I don't think it will survive indefinitely. Like, there will never be a replacement for ISIS, but I think it will stick around for some time. The way I describe ISIS is kind of like the beta versus VHS tape war that happened. Oh, it's been a while now. I remember when we first got a VHS recorder, a tape player for our TV, we got a beta. And that was back when there was really 2 standards out there, and there was 2 different video cassettes that you could get. Well, as many of you know, VHS won. Oh, that's the wrong tool. VHS won, but it won the consumer market. Beta was actually better. And if you get into video production, you find out that beta is still widely popular among professional video recording individuals. VHS is just used for the home market. Well, ISIS is just like that. It is the beta of the routing protocols. It is more tweakable and more tunable, more efficient than OSPF, but who won? Well, VHS did, or OSPF won the consumer market for routing because it's more understandable than ISIS. It has concepts in it that are simpler to understand if you really get with TCP/IP. You'll mainly find ISIS among the large ISPs. And that kind of brings me to a question that a lot of people ask. Are there a lot of new ISIS deployments that are out there? Well, not really. I wouldn't go into a business and set them up for ISIS, even though that's the protocol that I prefer. It's more tweakable, it's more tunable, like I just said. But I would never set a large business up for that, because who on earth understands ISIS besides the extremely technical people? Not many. So just for interoperability's sake, I would stick with something like OSPF. The reason it became popular among the large ISPs is because the US government originally mandated OSI support for the early internet, before the internet really took shape and took form using TCP/IP. OSI was the protocol that was used to run the foundation of the internet. And that kind of brings me to another point. You ever wonder where the OSI model came from? I mean, when I first learned the OSI model, I was like, what did this apply to? Well, truth be told, the OSI model was never really meant to be a model. It was meant to be a protocol. And there's a whole protocol suite that goes with that OSI model called the OSI protocol. Well, ISIS was originally the routing protocol that was developed for OSI. There's your trivia fact of the day. And that was foreseen as the one to take hold across the internet until TCP/IP came around and bumped it out. So ISIS stuck around while the OSI protocol virtually went away. And they modified ISIS and just put a word in front of it. Integrated. Integrated ISIS is a version of ISIS that can run TCP/IP. Essentially, I kind of think of it like my Pontiac Grand Am. That's the kind of car I drive around. It's nothing spectacular, but a few years back, we decided to drive to Missouri, and we wanted to haul a U-Haul trailer. So my little Grand Am car, forgive the artwork, that was never meant to pull a U-Haul, was modified. I put a little trailer hitch on that thing so you can haul a U-Haul with it. It makes a great conversation piece when people say, what can you haul with the Grand Am? Well, you can modify that Grand Am to haul a U-Haul. Well, in that same sense, they modified ISIS. They didn't really tweak the protocol itself. They just stuck a little hitch on ISIS. They put some extra room in the packet for it to carry TCP/IP information. And because of that, it is well positioned for IP version 6. When TCP/IP version 6 really takes root on the internet, ISIS will have very, very little modifications to make it work, because all you really need to do is take off the hitch or take off the U-Haul that you're hauling, which is IP version 4, and just put a new one on that is IP version 6. Very little modifications to the protocol itself, whereas things like RIP and OSPF will have to be completely rewritten. So that's kind of ISIS position in the market. A lot of these large ISPs are still running it because it still works well, and they have no real reason to change their complete infrastructure since they can run TCP/IP on top of ISIS. Let's dive deeper into ISIS, and here are the facts that you'll need to know regarding ISIS. This is one of the only other link state routing protocols that are out there in the market besides OSPF. And it does use Dijkstra's SPF algorithm to calculate the routing table. And I put a little ... there because people look at it and say, well, what's the big deal then? Why is it so much more efficient than OSPF on your processor and your memory and so on? Well, I put ... to calculate OSI routes. It uses a different algorithm called PRC, which is much more efficient than SPF on your processor and memory for the IP routing table, which is really all we need to calculate. It will run SPF once to figure out how to get around the network, and then from there on out, it will run PRC to calculate the entire IP routing table. This one is more efficient than SPF. And it was funny, somebody caught me off guard once. And they said, well, if that's so much more efficient than SPF, why doesn't OSPF run it? And I kind of sat there, I thought, well, wait a sec. I don't know. And I sat and I thought, and I go, wait a sec. There's the reason why. OSPF is a standards-based protocol. If you wanted OSPF to run PRC instead of the SPF algorithm, you would have to update every router in the world that's running OSPF. It'd be like gutting the OSPF protocol and putting a whole new engine inside of it. That would be a change as big as moving from TCP/IP version 4 to version 6, which we still haven't done, even though version 6 has been out for many years. So that is why PRC is not used in OSPF, is because it would require a major revision of all routers that are existing running OSPF. Now, this is a weird one. ISIS uses a metric called the default metric, which can lead to many confusing conversations when you're trying to describe what the metric is on an interface. What the default metric is, and that is the name of the metric, is just a digit that you set on each interface. It's kind of similar to this. You know how OSPF uses the bandwidth to figure out what the metric is for each individual route? Well, you have to go under each interface and accurately set the bandwidth for that to work correctly. For ISIS, you don't go into each interface and set the bandwidth. You go into each interface and set the default. Not any default as we think of the word default. That is literally the name of the metric for ISIS, and that's any value from 0 to 63. Since ISIS is quite old, that range can be a little bit limiting. not too limiting because you usually don't have that diverse of a link speed in your environment that you would have 64 different link speeds. But what I've seen people do and what I do when I set up an ISIS network is I'll make a little spreadsheet in Excel or something like that, and you open up that table and say, speed 63, which is the slowest possible link, that would be a 9600 baud modem or whatever the slowest link in your environment is, and then you'll accurately scale all the different metrics based on what their actual bandwidth is. It is a little bit more work. It's not as easy in your mind as just setting a bandwidth statement on OSPF, but that is the metric that ISIS supports. Now, the original standard supported 4 different types of metric. It was something like default, expense, error, and one other one. But on Cisco routers, Cisco only adopted the default metric. So that's the only one we really need to concern ourselves with. Now, ISIS, this is the cool part, does not have a backbone area. Remember in OSPF, we had the area 0, all areas must connect there? That kind of limited our flexibility with how we can scale our network, and everything has to be connected to that one major area. Instead, in ISIS, the backbone is a level. And for now, I'm going to leave it at that because I have a whole nother slide to explain how that level works. But just remember, we don't have this backbone area where everything has to connect to. Now, this is the thing that throws people on ISIS, is that in order to run ISIS, remember I said it was kind of like a grand dam with a hitch that it adapts it to TCP/IP? Well, in that same sense, ISIS is still designed for the OSI protocol, and because of that, you must assign your router a single OSI address. That's right. The OSI model describes an OSI protocol that had its own addressing scheme, and boy is it weird when you see it. You have to assign a single OSI address to your router for it to function properly using ISIS, and that's what I want to talk about right now. OSI addressing. The first thing I have to tell people is, yes, it is very strange. It's a strange address when you look at it. Here's some examples of it down here just so you can get a feel for it. And the reason I mention that is because it instantly turns a lot of people off to ISIS. They look at that address and go, oh, it's a weird address. I don't even want to mess with that. And they look to some other protocol. Well, you have to think about TCP/IP. When you first saw an IP address and a subnet mask and learned about subnetting, I know it's probably been a while, a long time ago, but it was very strange back then as well. A network and a host portion, how's that whole thing work? Well, an OSI address, I think, is a lot simpler than a TCP/IP address. So when we break it down, we'll look at that. It is a hexadecimal address, so we can see letters and numbers, letters going from A through F in there, so don't be surprised when you see those. Now, this is the big part. It is comprised of 3 parts. Every OSI address has 3 major pieces. And when you look at the original standard for OSI addresses, there's actually more. There's a lot of different components that makes up an address. But when Cisco adopted it on their routers, they did stick to the standard. It is industry compatible and industry compliant. However, they narrowed it down to 3 major pieces. There is an area ID, so by looking at that address, I will be able to determine the area that router is in. They have a system ID, and the closest thing you can compare that to is kind of like the host ID of an IP address. The system ID tells me what system in that area I am. And finally, you have something called an N cell or an N selector. And the closest thing you can compare that to is kind of a port number, saying what service are you accessing on that device. Now you notice I put how long each portion was. The N cell is 1 byte of information, system ID is 6 bytes, and the area ID is a variable length. Now they go in this order, and the reason I put these lengths is you have to learn to read these addresses from right to left, which if you're in American, you're used to reading a book, that is totally counterintuitive. You're used to going left to right. Here we go right to left, and here's how it works. With the N cell address, or I'm sorry, the N cell portion of the address, we have 1 byte of information, and thankfully on our Cisco routers, it is always 00. Remember I said it's like a port number? Well, with TCP/IP, what's a port tell you? It tells you what application you're accessing, right? Like port 80 goes to a web server. Port 21 is FTP. Well, you can think of this on an OSI router like port 00 is a router. It's always going to be 00. So when we look at our Cisco routers and we start the address, we already have a thumb up because we have to start it with 00 every time. From there, we have the system ID, which is 6 bytes long. There's another address out there that's 6 bytes long, or 48 bits in length. You know what it is? A MAC address. A MAC address assigned to our Ethernet interface is typically 48 bits in length, or 6 bytes long. So a common strategy that people do when they create an OSI address, because we only need to create one, is they will take the MAC address of their Ethernet interface and assign it to the OSI address. They'll make that part of it because that is guaranteed to be unique, and this system ID needs to be unique on your router. System. Okay, I spelled it right. No, I didn't. System. There we go. System ID needs to be unique on our router. Now, I'm also showing you an example down here where I've created a system ID. I'll kind of draw the lines right here. These are all system IDs. I'll draw this arrow right like this. I also created an example down here that is specific, in my opinion, to the CCIE lab. In the lab, you're going to have routers like router 1, router 2, and so on. A common strategy to make sure they're unique, and you won't even have to mess with MAC addresses and figuring out what those are and mistyping them and so on, is just to make them all ones. For router 1, make a system ID of all ones. Router 2, make it all twos, and so on. That system ID doesn't have any strict requirements, just that it must be 6 bytes in length. Now, the area ID is the only variable length part. And this is why it's so important that we read our address from right to left. We know the end cell is 1 byte. We know the system ID is 6 bytes. So whatever is left over will be the area ID. Do you see how impossible it would be if we were to read from left to right? We wouldn't know where the area ended and the system ID started because the area can be a variable length. So in this case, we see that the area is 49.0005. Now let me first off talk about 49. All these addresses start with it. Is that a requirement? Not at all. You can choose whatever number you'd like to start an address. However, 49 is considered a private address. And you know how in IP addresses we had like private ranges of addresses, 10, 172.16, and so on. In the OSI addressing world, private addresses or locally administered addresses started with 49. You didn't have to talk with the government to get an address if you were starting it with 49. So when I'm looking at this, I kind of abbreviate this and I say, well, this is a marker for area 5. The technical marker is 49.0005 is my area ID, but I say that's area 5. It's easier to say. Right here, I kind of did this one because I wanted you to see that it is a variable length, but we started with 49, but this area is 0152, 3156. So you can have some pretty wild area IDs here. This one at the top is area 3. That's how I would abbreviate it, but it's really 49.0003. So you see, by looking at an address on a Cisco router, we can see the area that that router belongs to, just like we had the OSPF areas. Let's look at some topologies on how this ties together in an ISIS network. Here's our first ISIS network. And this is just a simple topology to demonstrate the concepts. I've created 2 areas here with 4 routers, and I want to break down these addresses assigned to these routers one piece at a time. Right here, underlining, is the end cell, 00. And on Cisco routers, it will always be 00. From there, you see the router numbers, 3, and 4. I created a system ID to match those router numbers. So we just count another 6 bytes, or 48 bits in hexadecimal, and that will be our system ID. Very logical systems IDs we created. From there, whatever is left over is going to be the area. And I went ahead and put the area short name right here, area 1, but really the area ID as it is to ISIS is 49, that's a private address, 0001. Right there, we have 2 routers in the same area. Down here, we have 49,0,0,0,2. So two routers in the same area there. So they have to have the same area ID to communicate within their area. Now, for those people that are experienced and used to dealing with OSPF, there's something just wrong about this diagram. It just feels wrong. Let me point out what feels wrong about it, and I'll put our little OSPF router sitting up here. OSPF right on the router. With OSPF, we're used to the borders of areas lying kind of inside of the routers. For example, if the IP address on this interface is 1.1.1.1 and over here is 2.2.2.2, I would put those into the OSPF process by saying network 2.2.2.2 wildcard mask of 0000 area 1. So at this point, to the left of that router would be area 1. Now I would put this one in here by typing in network 1111, the wildcard mask of 0000, and I'd say area 0. So now the border of that area, it's like this router has a split personality. Half of it belongs to area 0 and half of it belongs to area 1. It's not that way in ISIS. A router belongs to an area. And you can see, since we only assign one OSI address to that router, it's only going to belong to one area. Its links will connect to routers in other areas. So the border, we don't have routers with split personalities anymore. We have links that span the areas, which kind of makes a little more sense, logically speaking, when you think about it. So we have our area borders that now lie on the links connecting together. Now you also notice, and maybe this is what feels wrong to you if that wasn't it, you notice there's no area 0. Well, that's the way it works with ISIS. You don't have a backbone area. Instead, you have a backbone level. Let's talk about that now. The ISIS routing protocol maintains two IP databases in its routing table. So it really has two different routing tables that it sets up. The level 1 database will contain intra-area routes. And if you think of the level 1 database, and we're comparing it to OSPF, because this is where most people come from when they get into ISIS, you can think of routers that have a level 1 database as kind of just your internal routers. They get you around the area, but they don't get you outside of the area. The level 2 database contains the backbone routes, ways to get around outside of the area. If you were to think of these, I guess the closest comparison you would have in OSPF is an area border router or an ABR that can get you outside of your areas. Now this is a big difference when we think about OSPF compared to ISIS. The routers may be a level 1, level 2, or a level 1/level 2 router, and this router would have both databases. And the best way to describe this is to look at this example of how this works. I've put together this topology, which in no way is a best practice for ISIS, because I put it together to demonstrate precisely the concepts. You'll see why as we go through. Here's area 2. Let's start down here. This is a level 1 router. The level 1 router knows how to get around area 2. But let's say we have a host connected right here off of this Ethernet segment, and its default gateway is pointed to right here. When it's saying, okay, I need to get to a router, or let's say a host, and pretend this WAN link is some very odd WAN link that has a computer connected to it. When it's going to get to this host, it's going to go to its default gateway, and it's going to say, oh yeah, no problem, that's in my area, I know how to get there, and it will send it directly to that computer. But let's say this computer wanted to get to a computer attached to a network in area 3. Well, as soon as it goes there, this level 1 router is inadequate. It doesn't know how to get to area 3. So its strategy will be to send it to the closest level 2 router inside of its area. So we'll look at the cost of its links, and it will say, oh, that must be the closest one. So it goes to this router, and this router says, well, I have the level 1 database, which just describes area 2. I need to refer to my level 2 database, which describes the backbone. Ah, that's a network in area 3. I need to get out of my area. So the request passes across the WAN link and now enters area 1. This router has a level 1/level 2 database, and again, let's make sure we understand that. It knows how to get around area 1, but also knows how to get around to other areas. That's the level 2 database. So right here is where I have my poor area design, because I really want to distinguish the difference between these databases. This router, the only link it will use to get to area 3 is this one right here. Why? Because this is the only backbone router. This is the only router that knows how to get to area 3. If it were to send it to this router right here, this request, this router would drop the packets because it would say, well, you're trying to get to some computer outside of my area. I have no idea what you're talking about. The reason I say it's a bad design is because if this router failed, what's going to happen? Well, we've just broken our backbone, if you will, to ISIS. See, here's the requirements, and this is a big one to catch. With ISIS, there is no backbone area. There is a backbone level. And that level must stay contiguous throughout all of your areas. You see this nice smooth backbone that we have here? If any one of these routers fail, we break our backbone and we leave these areas isolated. In essence, if this router failed, if this level 2 router went down, area 3 would be completely isolated from area 2 and vice versa. We'd have a break in the backbone. Yes, we could communicate kind of between these areas into area 1, but we can't communicate between them. Likewise, with this router, since that is the only level 1 router kind of between these two routers, if this one went down, we would lose our intra-area communication of area 1, meaning we would only be able to go through area 1. No more could a host, maybe this had an Ethernet segment over here with a computer. If this computer wanted to communicate with a computer attached to this computer, it wouldn't happen because that's within the area, and if that router went down, we would lose our intra-area communication. You see how that works? That's how the communication happens within these two databases. So a good design strategy at this point would be to make both of these level 1/level 2 routers, because those are some pretty core routers to our backbone and the intra-area communication. However, the reason we have this flexibility is because as you get into those large internet service providers, you may want to limit your backbone routers because that level 2 database could get pretty darn big. And the bigger the database, the bigger the routing table, and the less efficient your routing protocol becomes. With those concepts under our belt, let's get into the configuration of ISIS. Really, there's 4 major steps, 3 to be exact if you want to keep everything at the default. First off, enable ISIS on the router, and that's really easy. You just go into global config mode and type in router ISIS, followed by a tag if you'd like to. Remember the tag with OSPF? Very similar to that, and when we get into the live configuration, I'll show you what that means. From there, we configure a single OSI address per router. That's that address that you're going to create that has the area ID, the system ID, and the end cell. The slang for that address, I've heard a lot of people use this, is the net. So if you ever hear the net when you're referring to the ISIS protocol, that's probably the network address, the network OSI address that you've assigned to it. Now this one is cool. I love this about ISIS. You get to enable ISIS on a per interface basis. And when I say that, I mean from interface configuration mode, you turn on ISIS. That for me has been a huge bonus for ISIS, because with OSPF, where do we do it? Router config mode, right? You type in network followed by, well, I usually use the shortcut of the interface IP address, a wildcard mask of all zeros, and you tell what area it's in. I wish we could move that to an interface mode, because that would allow us to go under each individual interface, Ethernet 0, Serial 0, whatever, and just turn on the routing protocol. And that way you know exactly what interfaces are running ISIS and exactly what interfaces will be included in the routing table. From there, I have step 4, which could be a multitude of steps if you'd like to. I just have configure any options. That means authentication. That means what level routers we are wanting to be, if it's a level 1 or level 2 or both. What kind of connections we should have on the interface, whether it's to a level 1 router, to a level 2 router, and that sort of thing. All those options are totally up to you. Or you could leave everything at the default, and I'll walk you through each one of these as we jump into the live router right now. Here's the first thing I want to show you about ISIS, is that it is not a common protocol. Like I said, it's the beta of the videotape player. So I'm going to jump on this router, which I'm going to do a show version. You can see it's running 12.2 release 15T9, a pretty decent version of the iOS, pretty late version of the iOS. I'll put router ISIS, hit enter. Protocol not in this image. This is one of the things you'll probably encounter on most of the iOS images that you run in your network. In order to get the ISIS protocol, you'll need to run one of the Enterprise Edition softwares, one of the high-end Enterprise Editions, or some of the service provider editions have ISIS. So now with the 12.3 release of the iOS, they have the telco image. That one has ISIS. So any one of those, I have a router that I've equipped with the correct version, jumped over to router 3. And the first command that you're going to type in to start router ISIS is just that, router ISIS, followed by a tag. Now you notice that this isn't a number like it is with OSPF. It can be a word, it can be a number, it can be, well, it can be whatever you want it to be. What I would recommend is that you just leave it off. If you leave everything at the default and just type router ISIS, it will generate a default tag of 0. If we did a show running config now, we would see router ISIS 0 in that configuration. The reason I leave it off is because we're going to have to start assigning the interfaces to ISIS routing process and all of the other configuration. And if we put a tag on there, we're going to have to remember what that tag is. Rather than remembering the tag, I'll just leave everything at the default, which is 0. The funny thing is, once we're into this router process, into the router ISIS, there's only one thing that we need to do. We type in net, followed by that address, that OSI address, there we go, the OSI address that we want to assign to this router. Now this address will affect what area it's in, what system it's known as to the ISIS routing process. It really is the main piece, and that's why I spent so much time describing that address. So we'll put this in, I'll say the abbreviated area 1, 49, so it's a private address, 0001, followed by the system ID. Well, this is router 3, so let's go 3333, 3333, 3333, just like a MAC address. Now you notice it kind of gives you a little hint here just by looking at those last two. We go, oh yeah, we need that end cell or the port number that's always going to be 0. I hit enter and I've now assigned this router its OSI address. And if I want to leave everything at the default, that's all I need to do from router configuration mode. Now by default, this Cisco router will be an L1/L2 router, so it will maintain both databases. I'll show you how to modify that later, but for now let's just get ISIS running. I'm going to jump out and do a show IP interface brief, and we can see that we have the serial 0/0 and the loopback 0 in there. Let's put both of those in the ISIS routing process. To do that, we get into the interface configuration mode. I'll type in interface serial 0/0 and type in IP router ISIS. Now, if you put a tag on that ISIS routing process, meaning you didn't keep the default, this is where you have to type that in. You'd have to say, Jeremy, if that's the tag that you chose, or 5 if you chose a tag of 5. But since I didn't pick a tag, I'm going to leave the tag off, and that makes it a little bit easier. That's it. That's all there is to configure ISIS in its default state. We now have the routing process running. We now have it running in its own OSI address, and we get to choose what interfaces run ISIS. Rather than going and typing in network statements that can get pretty convoluted, we just go under the interface configuration mode and type in IP router ISIS. I'll go ahead and include that loopback interface in the ISIS routing process as well. Now remember, as soon as you type this under there, it's not only going to begin sending hello messages out on that interface, but it's also going to include that interface in all of its network updates and network advertisements that it sends out. So on this router 3, we're going to have the serial 0 interface, negotiating neighbor relationships, and we'll include the loopback interface in our routing update advertisements. Now that we have ISIS running, the first thing I want to show you is how to optimize it by changing the router level so that it will only run the databases that it needs. As I mentioned, ISIS is going to run as a level 1/level 2 router by default. What that means is you'll maintain 2 separate databases, eating up a little more memory on your router, and you will send out 2 separate hello messages. There's an interesting thing that I haven't mentioned yet. A level 1 relationship and a level 2 relationship each has its own hello messages. It's almost like you're running 2 different ISIS protocols on the same router because they act independently of each other. So if we want to change the router type as a whole, We do that from router configuration mode. We type in IS type, followed by what level of router we would like to use. And we can say this is a level 1, level 1-2, or level 2-only. And I always forget this only keyword on there because it's just something you never think of. I don't know why they just didn't put level 2, just like they had level 1, but I digress. That will change the entire router as a whole. If we want to just choose what relationships to form on an interface, we can do that as well. And let me get back to the whiteboard here just to give you an idea of what I mean. Let's say we have this ISIS router. It's a level 1/level 2 router, and it's connected to a router over here on a inexpensive WAN link because it seems a little bit floppy there. This one is a level 2 router, this one's a level 1, and we never want those to change. We never want this router to form a level 1 relationship over here and a level 2 relationship over here, regardless of what these administrators configure their routers as. Well, in that case, we're doing it from interface configuration mode. So we're going to go into the interface that connects to those neighboring routers, and we'll type in ISIS circuit type, to spell circuit right, circuit type, and now you get to choose what type of relationships you would like to form on that interface. Whatever I type in here will be the type of neighbor relationships it forms on serial 0/0. If I leave it at the default, remember everything is level 1/level 2, so you will form both of those databases with all your neighbors. Finally, the final thing that you'll do from interface configuration mode is you have to make sure you set that metric. Remember the metric that ISIS uses? The default metric? Well, we do that by typing in ISIS metric, a nice logical command, followed by what the metric is going to be. Now, this is a confusing statement, but by default, the default metric is 10 on every interface. So if you don't do this step, every link will be considered a speed of 10. Serial interfaces, Ethernet interfaces, whatever the links are, they will all be looked at as 10. So what does that mean? It means that ISIS is no better than RIP in the sense, other than the fact that it can go more than 16 hops, because it's going to see every link as an equal cost or as an equal hop. So in order to figure out the total cost, it would just add the tens as it reached between different neighbors. And then we would have, in this case, a total cost of 20 between those two separate neighbors. So again, that Excel spreadsheet or whatever form you want to use to match the default metric to the bandwidth, you can use, and you can modify it to be the appropriate metric under each interface for what the bandwidth level is under that interface. The final command that I'd like to show you in this ISIS world is how to create a summary address. This is done from router configuration mode. It's still not as good as EIGRP. I'll get into router ISIS, and you just type in summary address, followed by the type of address that you'd like to summarize. So I'll say, in this case, 172.16.0.0, my subnet mask. And then you get to say whether you'd like to put that summary address into the level 1 database or the level 2 database, or both. You could choose both the level 1 and level 2 database. And this is where it gets kind of mind-boggling, I guess is the word that I can use. You get to choose what database each and every route belongs to. You can put summary addresses in, you can put interfaces into the level 1, the level 2 database, depending on the type of neighbor relationships that you form on that interface. It can get mind-boggling when you start doing it, and when you start really laying out your entire topology. It's one of those things that you have to draw it, I think is the best way to put it. It's just like OSPF. When you start designing the areas and what areas go where your summary addresses are, it's the same thing. You have to draw it out on paper. And in the same sense, ISIS, you're going to have to figure out what databases you want what routes to belong in and how you want those routes to end up being reached. But let me give you the tip now, the tip of the day for ISIS. As a matter of fact, let me go ahead and jump back here, and I'm going to create a new slide just to have a blank template. And forgive me if I'm a little outside of the borders here. But when you are in the CCIE lab, and I'm going to focus specifically on the CCIE here, the ISIS protocol, hypothetically speaking, without giving too much away, will most likely be an edge protocol. So we'll have our routers, you'll be running, your core protocol. It'll be a huge network over here, which might be something like OSPF. And then you might have over here just this little world of ISIS that's running between 2 or 3 routers. Now, when you're doing this type of configuration, it's going to be very simple and to set up just that ISIS relationship. But there's a catch. When doing redistribution from ISIS, so let's say we had 172.16.0.0 over in this world, and we want to redistribute that into OSPF. ISIS, let me put an Ethernet interface over here of, we'll say 10.x. ISIS will have no problem redistributing networks that it learns about. So let's say this is router 1. It's learned via ISIS about the 10.x network. That will redistribute just fine. However, because of the way ISIS forms neighbor relationships and how the interfaces are placed in, when you do redistribution, this interface, and essentially I can tell you this network, 172.16, if that's what we used here, would not redistribute when redistributing ISIS. In order to make that work, you need to do a redistribute connected. Okay, so remember, whenever you're redistributing ISIS, for the connected interfaces, even though they are technically running ISIS, for those connected interfaces to end up into this OSPF domain, we would have to do a redistribute connected and then apply a route map to filter out exactly what connected interfaces go in there, because maybe you have an Ethernet interface over here and the serial interface. You don't want those to loop by redistributing them into OSPF as well. So we'd apply a route map to say just this interface, 172.16, will end up redistributing into OSPF. Forgive my sketch art on the screen. I just wanted to give you that tip for those of you going for the CCIE lab. So let's wind down this world of ISIS, and I want to just go through the main points that we hit in this nugget. The first one, and I hope I've done an adequate job of answering this question, does IS minus IS equals 0? The answer is no. It's a fantastic routing protocol. It's just misunderstood. It's so specialized that not many people use it. We then got into the facts about ISIS, the fact that it is linked state, the fact that it does run on OSI. It was designed for the OSI protocol, and because of that, we needed to understand the OSI addressing. And if there's one thing that I hope I adequately covered in this nugget, it was how to address your router and how to understand that OSI address, because that is it. I mean, that's the main part of ISIS that confuses people. Okay, the secondary part is the network design. The fact that there is no backbone area. There's only level 2 routers that have to maintain consistency throughout that network. There is no area 0. But the great thing about that is it gives us more flexibility with how our network is designed. We don't have to have all these areas around the world connected to area 0 and everybody using virtual links when we couldn't make that connection. No, we just extend the backbone a little bit more by adding a few more level 2 routers. So that's the power and flexibility we have with ISIS. Finally, what I thought was the easy part is the ISIS configuration. Because ISIS is so conceptually heavy, the configuration is just 2 or 3 commands. Turn on the routing process, assign an OSI address, then jump under each interface that you'd like to run ISIS, and just type in IP router ISIS to get it up and running. It's very straightforward on that configuration. So I hope this has been informative for you, and I'd like to thank you for viewing.